Hello, this is part two of our discussion of climate change and global warming in Weather and Climate, Geography 306. Um, so this is where we left off, and again, among the thousands of professional expert scientists, there isn't really a controversy or an argument about whether A, the globe is warming, and whether B, humans are a very strong, significant factor in that. These things are both true. This again brings up another question: is, well, why do we care? What's going to happen? And some people say that scientists can't predict this or that, and in fact, scientists going back a couple of decades predicted a number of impacts as a result of global warming, and we are seeing all of them. So I'm not sure where people get their evidence to say that nothing that scientists have predicted has come true, because virtually all of it has. And slight differences in the measurement here and there occur. But let's take a look. So in your notes, what are the major consequences? And this is really not a completely comprehensive list. This is the high points. And I'm going to show you some slides that walk us through a little bit of this. First of all, again, predicted decades ago that we would see changes in natural plant and animal distributions, where we find certain plants and certain animals and insects on the land and in the oceans of the world. This is just one little example of the Carolina chickadee and the black-capped chickadee. These are birds that are both related. Bird watchers review bird locations pretty thoroughly over long periods of time. And so what you see here in this map is that the gray is where those birds were found and where they continue to be found. The orange is where they have disappeared over the last several decades, and the green is where they have newly appeared over the last several decades. So what do we see about this bird? It is marching northward. And you might call this a success story for the survival of this bird. There's plenty of plants and animals that will not find it as easy to shift over the span of time that is required. They may be barriers in the way, highways in the way. It really depends on the species. This will definitely result in extinctions, and we are already seeing extinctions of plants and animals related to climate change. So here's another one. The gray for the black-capped chickadee is where they have always been found. The orange is where they have disappeared from, and the green is where they are newly being sighted. And there are literally thousands and thousands of examples of plants and animals that are shifting in response to climate change. This is happening before our very eyes. And as I said, this will result in the disappearance of some species. Also in your notes, it mentions agricultural crop failures. Now that might be a slightly alarmist way to phrase it, but farmers all over the world are seeing their business and their activities impacted by global warming. So I just pulled a fairly recent article from a respected publication that talks about impacts of climate change on agriculture. So we certainly, because of how important agriculture is globally to feed people, this is something that obviously needs to be paid attention to. And in your homework touched on this very topic, human health issues. So this is, let me move that. This is this is a map showing over from 1961 to 2017 the frequency of heat waves in major cities and how long the heat waves have been lasting, how long the heat wave season has lasted. So what do we see? We see clearly an increase in the number of heat waves, and we can look at define that. That's not necessarily important right at the moment, but and how long the season, how many days during the summer from the first heat wave to the last heat wave there are, and this has expanded. Well, what we know about heat waves is people who are frail, people who are elderly. It causes significant health emergencies, and it causes some mortality. So this is no small matter. The science quite clearly says that global warming is impacting human health. Also mentioned in your notes, water resources, impact on water resources. This is a set of maps for California. So this is the historical average in how much water is found in the mountains. So you see here, the Sierra is a giant, basically giant free reservoir that we never had to pay for and we never had to build, and a reservoir that delivers water to us here in the Central Valley exactly when it starts to warm up and dry out down here. So it's really an amazing natural relationship that we have with water in California if we manage it correctly. But what are we already seeing? We're seeing less and less snow. We're seeing the snowpack shrink and shrink over time. These are the estimates for depending on the change in climate, depending on how humans address these concerns. If we have less warming, we'll probably have 40% size of the snowpack. So it'll, under a good circumstance, it'll shrink by a little more than half. And under the worst circumstance, it may shrink by 80% with only 20% remaining. So this means that California will need to shift the way it does business and address our relationship with water if we want to move confidently into the 21st century. And coastal flooding in relation to sea level rise. This is a map, and it shows 2018 and the outlook for 2019. This is NOAA, the National Oceanic and Atmospheric Administration, and what it is showing is projected high tide flood days in 2019. This was at the time the most recent data I could find. High tide flooding is literally places where human habitation, dwellings, and roads and stuff that people build gets flooded by high tides. Well, that never used to happen. But in the last approximately 100 years or so, we have seen an increase in high tide flooding all over the world. It happens in California. It happens a lot on the East Coast. And, you know, in a nutshell, the oceans are rising. The estimates, we've been measuring the level of the ocean for a long time. Tides are a big deal when it comes to shipping, and so harbors all over the world for hundreds of years have been keeping close track of how high the water is and the timing of tides. And what we've noticed is approximately 6 inches increase in ocean levels around the world over the last century, over the last 100 years, and that's what your homework says. That's somewhere between 10 and 20 centimeters. 15 centimeters is approximately 6 inches. So this map shows briefly where people will be influenced by rising sea levels. Number of people who are living on land expected to be under sea level by 2100. So what the estimates are up to 70 centimeters. Some estimates are higher than that, up to a meter. That would be 100 centimeters globally. And so you can see the approximate numbers of how many people, if this goes unchecked, will be living on land that would be underwater within approximately 80 years. So again, this is no small issue. Now, the question is, why is sea level rising? And these slides aren't terribly recent, but let me put this in a nutshell. There's basically 2 reasons that sea level would go up and down in response to climate change. So first of all, glaciers and ice sheets. So glaciers in the mountains, giant ice sheets at high latitudes like Greenland and Antarctica. When it gets colder, they expand, of course, and that water is basically pulled out of the ocean. So ocean level goes down. So as temperature goes down, sea level goes down. Well, as temperature increases, sea level increases. because when those glaciers and ice sheets melt, that water flows downhill, 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 and fills up the ocean, literally just like pouring water into a glass fills up the level of water in a glass. So that is one factor. Again, we are seeing that right now. We are seeing evidence. All glaciers and ice sheets all over the world are losing tonnage, and that is well documented. There are a few that have grown, but those are in the extreme minority. And then the second double whammy is that ocean water itself, as it warms up, expands. So when the air expands and melts the glaciers, ultimately the ocean water warms and it expands in all directions, including upward. So again, you see here current sea level trends, sea level rise during the last century between 4 and 8 inches. So rounded off about 6 inches. And then again, what are the estimates of sea level rise in the future by 2100? They are varied and really depend on how humans respond to climate change. So there are definitely estimates up to and even over a meter of increase from current sea level. So I'm going to move through these. These just show various instances of breakup of ice sheets and glaciers. This shows warming of the oceans worldwide. This is an interesting map which doesn't necessarily show predicted changes, but what you see if you look at the light green is the coastline of modern North America. Well, the gray is the coastline that existed approximately 15,000 years ago when we were at a glacial maximum. So we had lots of glacial ice, lots of the ocean water was sucked up and locked into glaciers worldwide. And when the ocean level goes down, all of this gray land appears, is uncovered. So that's why if anybody has studied anthropology and looked at the Bering Land Bridge, you can see it up here. During colder periods, more land is exposed because all of that ocean water is locked up into glaciers. Conversely, the calculations are if we were to melt all of the glaciers worldwide, which nobody is saying we do that, but just to make a point here, if we were to melt all the glaciers worldwide, sea level would increase and it would cover all of this light green. So you can see Florida would be completely disappear. This is the Mississippi River Valley. This is the Central Valley of California, sea level. And now, again, nobody is saying it's going to be this dramatic, but you see how amount of land changes in response to sea level. This is documentation of sea ice, which is also decreasing, and this data isn't even that up to date, but the most up to date data continues to illustrate that ocean ice is shrinking. Now, before I move on to this, so there's a question of what can be done, and there is a lot that could be done. It just depends on whether there's the political will and the consensus. I reference here the very first international meeting where countries got together to discuss this goes back to 1997 in Kyoto, Japan. And the agreement there, basically, to pay attention and start working on this issue was referred to as the Kyoto Protocol. Well, international representatives from countries all over the world have been meeting since then, so over the last 20 plus years in major meetings all around the world. The most recent major meeting was in Paris, and that resulted in the Paris Climate Accords, which currently, this is being videoed in 2020, the United States has backed out of, again, expressing the concern that it's essentially bad for business to try to respond to climate change. And I would always say it's global warming itself is going to be very bad for business if we don't respond in a really logical, responsible way. So, what are countries talking about doing? First of all, countries are discussing and coming up with a pledge to reduce emissions. And I call this the permission to pollute. So everybody's working with each other to come up with each other's permission to pollute. And this is an incredibly difficult challenge. But ultimately, countries that have higher population and higher levels of industry, so that's China, that's the United States, basically get the permission to pollute the most because their economies are fundamentally based on um, um, these kind of burning of fossil fuels currently. But the idea is that every country in the world would, over time, reduce by a certain percentage. So if you started way up here and somebody was way down here and everybody goes down, it reduces emissions worldwide. Emissions of what? Greenhouse gases. Also, a big part of these discussions is emissions reducing technology. How do we develop that? How do we share it with countries? The fact is some people have a concern that this takes away the United States competitive advantage. I will say that I want countries who pollute a lot to pollute less. And I think that they should get access to cleaner burning technologies. So, what is on this list? Cleaner burning fossil fuel technologies. Certainly, many people would argue this is important, but that we need to ultimately start moving away from fossil fuel technologies, and that is not going to be easy. That is a challenge. Renewable, non-fossil fuel energy technologies. So this is solar, this is wind, this is harnessing tides. There are many, many promising possibilities. Also, let me say that this not mentioned in here, but would be energy storage. So battery storage has been something that is challenging. People say, well, when the sun goes down, we don't have solar energy. But if we can find a way to store that energy, then that really becomes a game changer. And there are people who are working on this. So again, this is a brief summary of an incredibly robust field of research. And then last on this list is carbon sequestration technologies. How do we take carbon out of the atmosphere? And that's what this slide was here. There are companies working on trying to essentially filter the carbon dioxide from the atmosphere and make useful fuels or products out of it. This is still experimental. Nobody has ramped this up at any incredibly large scale, but it is being looked into. The simple version of carbon sequestration, green plants suck in CO2. So some people are saying if we make sure to replant forests, some people are saying that they can harness algae to suck in CO2. All of these things need to be taken a look at. Also on the list is this idea of emissions trading, or cap and trade, some people may have heard about. And in the discussion with countries internationally, but also this comes up when discussing within countries, is the idea of setting some flexibility into these pledge to reduce emissions. So emissions trading essentially says that you want to try to build a system of incentives and disincentives. So incentivize polluting less, give tax breaks to people who pollute less. What is the opposite of that? And again, some people find this objectionable, but disincentivize pollution, so that create some fees or extra taxes for people who over pollute. And again, nobody wants to. Companies make money by being efficient, by putting out less money. So the whole idea is that this is going to promote cleaner burning air. So again, emissions trading just says that create systems that benefit people who pollute less, that slightly penalize companies and countries that pollute more, and then ultimately, even if some are above and some are below, and everybody keeps moving down, then we will globally reduce emissions. So the best way to think of emissions trading is to think of building flexibility into this system of reducing emissions. And then lastly, for a long time, as I've been studying this and teaching about this, the focus was on slowing down or stopping global warming. And what we know is that that is still possible, but ultimately the focus has moved much more toward adapting to a warmer world. That is what people all over the world are doing. That is the subject of your homework in this case, is how do we adapt to a warmer world in a way that won't cause as much disruption. Finally, lastly, in this section, scientists often talk about the no regrets philosophy. Now, people will say, well, what if scientists tell us to make all these changes and then it doesn't have an impact on slowing warming, okay? And everything says that if we put less greenhouse gas in the atmosphere, we will slow down warming. Everything says that. But even if it didn't slow down warming, the beauty of taking all of these actions, the reason we shouldn't regret taking action, that's why it's called the no regrets philosophy, is that it will result in so many other significant benefits. So you see here, benefits to society and the environment. We will clean the air by doing this. We will clean the water. We will seek energy independence. We will reduce pollution-related health problems, and on and on and on. So we should not worry that we're going to regret having taken action to address global warming and climate change, because even if it doesn't slow down warming like we want, which everything says it will have so many other hugely substantial benefits that we will have no reason to regret. So that concludes our discussion for Weather and Climate, Geography 306 on climate change and global warming. Thank you for your valuable time.